In this example, I'm going to use long division to divide this polynomial, I won't read it to you, by 3x minus 5. Okay, and we have to use long division, by the way, so if you've been exposed to synthetic division, we can't use that here because of the coefficient on x there, or at least not the way it's written. And the plan here is to use long division. I'm tripping over my wires. Okay, so first, the way we set this up, you should put the 3x minus 5 over here, and we're dividing that into 15x cubed minus 31x squared plus 31x minus 35. In each step of the long division, you really just focus on the leading terms. So in this case, right now, we would focus on dividing 15x cubed by 3x. So when you divide the x cubed by x to the first, that gives you x squared. And then divide 15 by 3, so that's 5. So the first quantity that I'm going to put up here above the division symbol is 5x squared. And I like to line it up with the squared term below. That's not a requirement. One advantage to writing it that way is you have some idea how much longer this is going to go before we have a solution. So there's going to be 2 more times around this division before we're done. Now, what we do here, this is similar to when you do long division of whole numbers, like when you're in grade school. We multiply what's up here by what we have over here. And I guess here I'm going to stick with blue so you can see the stages of this problem. So 5x squared times this entire quantity, 3x minus 5. So 5x squared times 3x would be 15x cubed. So I make sure that I put that in the x cubed column. You want to line up your like terms when you do this. And then 5x squared times negative 5x would be negative 25x squared. Now I should subtract this polynomial from the one above it. So I want to subtract at this point. I like to leave the negative out front and put parentheses around the product that we just found. If you want, you can change the signs across, go ahead and change the signs across this polynomial. Either way is fine. So I have 15x cubed minus 15x cubed, so the leading term is gone, and that's what should happen every single time, by the way. Now I have negative 31x squared minus this negative, so actually plus 25x squared. So when this negative distributes over here, this becomes a plus, and so when you combine those, this will be negative 6x squared. Okay, and that's all that remains of this polynomial here. Well, this bit anyway, when we subtract. We should bring down these remaining terms though, so plus 31x, because you're subtracting 0x to the first, and no constant term. So we can just bring these terms straight down here. And I'm sorry, there's the glare from my laptop here. Kind of a low-tech setup I have here. Okay, but so now we keep going. You repeat this entire process until the degree of what's left down here is lower than the degree of this 3x minus 5, which, since this is degree 1, we have to keep going through this same process until the degree of what's left down here is 0, since it's got to be lower than this degree, which is degree 1. So in other words, we're going to have to keep going until what we're left with is just a constant term. Okay, so we go around again. Like I said before though, you focus on just the leading terms when you do the division. So now we divide negative 6x squared by 3x. So when you divide negative 6 by 3, that'll be negative 2. Divide x squared by x to the first, you're left with x to the first. So we put that up here, minus 2x. Now I distribute that negative 2x times 3x minus 5. So negative 2x times 3x would be negative 6x squared, and it should match exactly with what's above. If it doesn't, then something's gone wrong. And then negative 2x times negative 5 is positive 10x. Now you subtract that from what's above. So you have negative 6x plus 6x, so the x squared, I should say. So the x squareds are gone. 31x minus 10x, because remember this negative distributes, minus 10x, so this is positive 21x. And then you bring down the remaining term here, so minus 35. The degrees now are the same. We should go around one more time because the degree of what's the remainder, the degree of what's left down here, needs to be lower than the degree of this 3x minus 5, not equal. So we repeat that process one more time. Again, divide leading terms, so divide 21x by 3x. So that comes out to 7, because the x's cancel. So this is positive 7 up here. Distribute that positive 7 over the 3x minus 5, so that's 21x minus 35. Subtract from what's above, well, we have 21x minus 35 minus itself, so the remainder here is going to be 0. The remainder in this case happens to be 0. Which means that the quotient, when you divide 15x cubed minus 31x squared plus 31x minus 35 by 3x minus 5, the quotient is this right here. This is what we call the quotient. What's down here is what we call the remainder. In this case, the remainder is 0. And so the result here, what we've discovered, is that this polynomial, 15x cubed minus 31x squared plus 31x minus 35 divided by 3x minus 5 is equal to the quotient, which is 5x squared minus 2x plus 7. I'm going to get rid of some of this long division for a second because there's one other thing I want to mention. Because in this scenario, when the remainder is 0, so if you had some remainder, let's say 15, we would have put plus 15 over 3x minus 5. That's usually the way we express our remainder. It's whatever leftover bit you have that still needs to be divided by 3x minus 5. However, in this case, the remainder was 0. So, and we don't write plus 0 for 3x minus 5 because that's just 0, so we can just leave that off. Which means, so in this special case, when your remainder is 0, notice that, so here's the division we did. Notice that if I take this equation and multiply both sides by 3x minus 5, multiply by 3x minus 5 over here, then the 3x minus 5 would cancel. And so what we've done, actually, through this division, is we've divided out that factor 3x minus 5. So this will come in handy later on, that when you know a certain expression is a factor of a polynomial, you can use long division to factor it out. Because even if somebody said to us, say we're trying to factor this expression here, and somebody walks up and says to us, well, hey, 3x minus 5 should factor out that. It's still, you can't just look at it and say, oh yeah, it's 3x minus 5 times 5x squared minus 2x plus 7. That's not going to be obvious to anyone. But so the way that you would, if you somehow know that a certain expression is a factor, the way that you can factor it out is just by dividing it out through division of polynomials, so through the long division.